You know that feeling, right? That tension, that pressure we call stress. We all feel it. But here's the thing. While we're feeling it in our heads, there's this incredible, much deeper story unfolding inside our bodies. It's like a silent alarm is going off, and today we're going to figure out exactly what happens when it does. And hey, this isn't some rare thing. Just look at this number, 76%. That's the percentage of adults who felt at least one physical symptom of stress in just the last month. Well, it's pretty much all of us. It's a universal part of life now. And you know exactly what I'm talking about, right? It's that feeling when you're late for a meeting, stuck in traffic, just staring at the clock. Or maybe you're at your desk and it's just piled high with a workload that feels impossible. Yep, those are the moments those alarm bells start to ring. Okay, but let's go deeper. Let's get past just the feeling of being stressed. What is actually happening inside your body when that alarm goes off? What's the biological chain reaction? What kind of machinery is kicking into gear inside your brain, your blood, even down to your cells? So here's our roadmap for this explainer. We're going to follow the clues, kind of like detectives. We'll start with the body's alarm system, then see how it puts the brain under siege. We'll uncover inflammation's role and even look at how stress can literally age us. Then we'll trace the domino effect on our health and, maybe most importantly, talk about how to build resilience. All right, let's dive into section 1, the body's alarm system. And the first thing to get is that this isn't some bug in our system. It's not a modern malfunction. It's actually a super sophisticated survival circuit that's been honed over thousands and thousands of years to keep us safe. So think of it like this super fast chain reaction. It all kicks off when your hypothalamus, which is kind of like the brain's control tower, senses a threat. Instantly, it shoots a signal down to your adrenal glands. And bam! They flood your system with a surge of hormones. And there are two main players here that we need to know: adrenaline and cortisol. And cortisol, that's the one we're really going to focus on. It's the body's main stress hormone. So what does it do? Well, its job is to dump a bunch of sugar into your bloodstream for a quick burst of energy. And at the same time, it tells other systems to kind of chill out for a minute, things that aren't essential for survival right now, like digestion or parts of your immune response. And we've got to be clear about this. For a short-term, immediate threat, this whole fight-or-flight system is absolutely brilliant. I mean, it's an evolutionary masterpiece. It was literally designed to save your life by giving you the juice you need to either fight off a danger or run away from it. So we've established it's a brilliant tool for short-term survival. But what happens when that alarm bell doesn't just ring every once in a while? What happens to our brain when it stays on constantly? Well, it basically creates this kind of civil war inside your brain. On one side, you've got your amygdala. That's your brain's fear center. And it just becomes hyperactive. You're on high alert 24/7. But at the exact same time, your prefrontal cortex, the part in charge of rational thought, judgment, impulse control, its activity gets turned way down. So it's like your emotional gas pedal is floored, but someone just cut the lines to your rational brakes. And the consequences of that internal battle, they're huge. I mean, when your fear center is in overdrive and your logical brain is kind of offline, is it any wonder it's hard to concentrate or that your memory starts to get a little fuzzy? This exact imbalance is what can lead to feeling emotionally all over the place, and it makes you much more vulnerable to things like mood disorders. Okay, this brings us to the real core of the mystery. We get the feeling, we see what it's doing to the brain, but how does all this lead to actual physical disease? Well, the central clue, the thing that connects it all, is inflammation. See, the whole system is designed to have an off switch. A threat appears, the alarm goes off, the threat passes, the alarm turns off, and everything goes back to normal. The real problem starts when the stressors in our lives don't go away, and that fight or flight reaction gets stuck in the on position. So what happens when that system is always on? Well, scientists are now pretty sure the answer is chronic, low-grade inflammation. And I love this quote. They describe it as the common soil where so many of our most serious long-term diseases can actually start to grow. And this isn't just some abstract idea, by the way. It's something you can literally measure. Chronic stress leads to a spike in these inflammatory markers in your blood, things like IL-6 and CRP. Now, they might just sound like acronyms, but what they really are is biological red flags, and they're directly linked to really serious conditions, everything from atherosclerosis, the hardening of your arteries, all the way to depression. But wait, the story gets even more incredible. because the impact of all this inflammation isn't just happening throughout your body. It's happening at the most fundamental level possible. We're talking inside your actual cells. Yeah, this process actually has a name. Scientists call it inflammaging. And it's pretty much exactly what it sounds like, a nasty mashup of inflammation and aging, where each one makes the other worse in this dangerous feedback loop. So here's how it works on a tiny, tiny scale. This constant low-level fire of inflammation literally wears away at something called your telomeres. The best way to think of telomeres is like those little plastic caps on the ends of your shoelaces, right? They protect your DNA from fraying every time a cell divides. And when stress and inflammation start shortening those telomeres, your cells just age faster. It's as simple as that. So let's just step back and connect the dots here. You've got a brain under siege, you've got chronic inflammation running rampant, and you've got your cells aging faster than they should. When you put all that together, what you get is a devastating domino effect that ripples through pretty much every system in your body. I mean, the list of health problems linked back to chronic stress is it's staggering. And it touches everything. We're talking an increased risk of heart disease, heart attack, stroke, type 2 diabetes, which is fueled by all those constant sugar surges. Even things you might not connect, like digestive problems, constant headaches, muscle pain, sleep issues, a weakened immune system. It all traces back to that one silent alarm being stuck in the on position. Okay, I know this all sounds incredibly bleak, and you might be feeling a little stressed just hearing about it. But the science doesn't just stop at the problem. The final part of our story today is all about the solution. And it's a story of hope, and a story about the power we have to actually change things. And that hope has a scientific name, neural plasticity. This is the incredible idea that our brains are not set in stone. They have this absolutely remarkable ability to adapt, to change. Your brain can literally rewire itself and bounce back from the damage that stress causes. And what's really cool is that we can actively help our brains do that rewiring. Look, these aren't just nice, feel-good ideas. They are scientifically proven ways to lower cortisol and build resilience. Getting regular exercise, actually prioritizing 7 to 9 hours of sleep, those things directly fight the physical effects. And then things like relaxation exercises, deep breathing, fostering healthy friendships, making time for a hobby, all of those things work to finally turn that darn alarm system off. So that leaves us with a final question to think about. Look, stress is an unavoidable part of life. We're never going to get rid of it completely. But is its impact on our health inevitable? The science seems to say no. By understanding what's actually happening inside our bodies, we get the power back. We gain the ability to manage it. The alarm will always be there, sure, but we're the ones who can learn to control the switch.